This is the solution to the APES FRQ 2012 number 2. Again, we are focusing on the mathematical calculations, so it doesn't have all of the parts from the FRQ. So if you're interested in looking at the environmental aspect of this problem, you would Google APES FRQ 2012. Typically when you do that, the first thing that comes up is the scoring guide, but the second thing that comes up is the question. So you can look at the question, look at the scoring guide, and see, try it on your own, see if you get it correct, whatever you'd like to do. So like I said, we're going to focus on the mathematical calculation part, which is part C. So the question reads, the Fremont School District uses oil to heat school buildings. Go green. Is a new project that the district will implement. The superintendent has declared that the district will dedicate itself to reducing its carbon footprint. In addition to taking serious energy conservation measures, the district is planning to help offset its carbon dioxide emission by raising money to help conserve a portion of a large tract of forest land adjacent to the high school campus. So we're going to use the assumptions below to answer the questions that follow. For each calculation, you need to show your work. We'll go ahead and go over this table with each part. So part 1 of part C, we want to calculate the mass of carbon in kilograms that is accumulated and stored in 1 hectare, I think is how you say it, of forest in 1 year. Here we want to focus on kilogram. When we're looking at it, that's what our answer needs to be in, right? We are calculating the mass of carbon in kilograms. Now, what we're starting with is what is stored in 1 hectare. And so what we're really looking for is a value that kind of has both. So if we're looking at the table, we see that the biomass of the forest increases at an annual rate of 2.7 times 10 to the 5th kilograms per hectare. And so if we start off with 1 hectare, that's the amount of the forest, right? And if we were to multiply by this value, kilograms over hectares, hectares over hectares is going to cancel, and we're going to get an answer in kilograms. So this right here is going to be important to help get us into kilograms. So that's definitely something that we can use. Next, the forest biomass is 50% carbon by mass. Now we are calculating the mass of carbon. And in the first one that we highlighted, we're looking at biomass of the forest. And so this one is also going to be important for what we're doing here because it relates to the problem that we're looking at. Next, each year the district uses 3.0 times 10 to the 5th gallons of fuel oil for heating in hot water. It's not kilograms, it's not the forest, so that's not going to pertain here. 10 kilograms of CO2 is produced when 1 gallon of fuel is burned. It has kilograms there, but we're not dealing with gallons or fuel in this part of the problem. 1 kilogram of CO2 contains 0.27 kilograms of carbon. Again, we're not dealing with CO2 in this part of the problem. And then cost of putting 1 hectare of the forest into conservancy is $12,000. We're not worried about money yet. So I think that these first two are the ones that relate best to this part of the problem. And so if you're ever not sure, you just go with whatever comes closest to giving you an answer that makes sense. So like I said, we are starting with 1 hectare. If we multiply 1 hectare times that first part of the table, the 2.7 times 10 to the 5th kilograms over hectare, like I said, we're going to see that hectare over hectare is going to cancel. But we do want to remember that second part of the table where the forest biomass is 50% carbon by mass. So there we see, sorry, in the PowerPoint, the hectare over hectare canceling. And so we need to think about that 50%. Now 50%, to get it into a decimal, we divide by 100, so it would be 0.5. To get it into scientific notation, we move the decimal point 1 to the right, which means that we would balance that by subtracting 1 from the exponent. So here we go, multiplying across. We have 1 times 2.7 is 2.7. Then we have 2.7 times 5. So I'm going to think of it as the distributive property. 2 plus 0.7 times 5. So 2 times 5 is 10. 0.7 times 5, 7 times 5 is 35. Then move the decimal one place to the left for the 0.7, and we get 3.5. So 10 plus 3.5 is 13.5. And then our exponents, 10 to the 5th times 10 to the 1st, it's multiplication, so we subtract our exponents. 5 plus -1 is 4. So we get 13.5 times 10 to the 4th kilograms. This is not in scientific notation, so we need to get it there. To get it into scientific notation, we need to move the decimal place 1 to the left. That would be 1 smaller, and so to balance that place value, we would increase the exponent by 1, so that would be 1.35 times 10 to the 5th kilograms. And again, this is the amount of carbon that is stored in 1 hectare of forest per year. Moving on to part 2. Calculate the mass of carbon in kilograms that was emitted by the school as a result of its fuel oil consumption in 1 year. So again, we are focusing on carbon in kilograms, and now we are focusing on the school. And so we want to highlight the parts of the table that have to do with this. And so when I see the carbon, we're looking at this one. This is the one that we haven't used, where we see the 1 kilogram of CO2 contains 0.27 kilograms of carbon. And what has to do with the school? Well, each year the district uses 3 times 10 to the 5th gallons of fuel oil for heating and hot water. And then we have to have a way to connect them. And so the first one that we highlighted has CO2 in it, and the second one that we highlighted has gallons. And so if you look at the box in between them, we have 10 kilograms of CO2 is produced when 1 gallon of fuel oil is burned. And so that's going to be our link. And so when we think about dimensional analysis, it's all about linking our units so that they cancel when one is in the numerator, one is in the denominator, and we get where we want to go. And so we're going to start with the gallons. We're going to start with 3.0 times 10 to the 5th gallons. Now, we don't want our answer in gallons. We want our answer in kilograms. So I need to cancel gallons. So my next unit factor that I'm going to create is we have 10 kilograms of CO2 is equal to 1 gallon of fuel. So if they're equal, we can set them as a fraction. So we're going to multiply by 10 kilograms of CO2 over 1 gallon. Then we want to get our answer in kilograms. So we see the kilograms of CO2. So in the last box that's highlighted, 1 kilogram of CO2 contains or is equal to 0.27 kilograms of carbon. We want kilograms of carbon as our answer. That's highlighted in orange at the beginning. And so in order to cancel kilograms of CO2 in our equation, right now we have it in the numerator, so we need to have it in the denominator. So we're going to have 0.27 kilograms of carbon over 1 kilogram of CO2. So let's see what cancels. We have gallons in the numerator and the denominator, so gallons are gone. And then we have kilograms of CO2 in the numerator and denominator, so that's gone. So our answer is in kilograms of carbon. So now let's go ahead and multiply across the top. And so 3 times 10 is 30. And then 30 times 20.27 is 8.1. So we end up with 8.1 times 10 to the 5th kilograms of carbon. Moving on to part 3, we want to calculate the number of hectares of forest the school district needs to conserve in order to offset the carbon released in 1 year by the school burning its fuel. And so what we're looking at here is how much is stored in the forest, and we want that to be balanced with how much they're offsetting. And so they are offsetting, right? 8.1 times 10 to the fifth kilograms of carbon. That's what we found in part 2. Now, we need to look at how much is stored in the forest so that we can balance that. And so in part 1, we found that there was 1.35 times 10 to the fifth kilograms in 1 hectare. Now, the reason why the 1.35 times 10 to the fifth kilograms is in the denominator is I want my answer in hectares. So that means that kilograms have to cancel. So all the stuff that we've been doing with dimensional analysis, we need to have kilograms in the numerator and kilograms in the denominator in order for them to cancel. And so we would do 8.1 divided by 1.35, which is 6, and then 10 to the fifth power divided by 10 to the fifth power is equal to 1. And so we end up with 6 hectares as our answer for part 3. Again, just reiterating, from part 1, we found that the mass of carbon stored in 1 hectare of forest, and that is how we got that unit factor. The 1 hectare is equal to 1.35 times 10 to the fifth kilograms of carbon. Part 4, we want to calculate the amount of money the school district must raise for the conservation project. And so we can see money is the main priority of this part of the problem. And so we look to the table to see what information has to deal with money. So the cost of putting 1 hectare of the forest into conservancy is $12,000. And so in part 3, we found the number of hectares that would have to be conserved, which is 6. And so we would use this unit conversion that $12,000 is equal to 1 hectare. We would put hectares in the denominator so that hectares over hectares cancel. 6 times 12,000 is 72,000, so this would be $72,000 is what it would cost the school district to run the conservation project. So, oh, there we go. I thought I had it in there. Hectares over hectares ends up canceling. All right, thanks.